All right, good morning, everyone. Thank you so much for joining us this morning for Water Around the World, Local Problems, Global Solutions. My name is Kando Pulse. I am the program builder at Current, and I'll be serving as our moderator for today. Water Around the World is a webinar series that we started this year to highlight water-related problems across the US and innovative global solutions for those problems. Before we get started today, I'd love to take a minute to thank our event partners, the Consulate General of Israel to the Midwest and Water Consulting. Go ahead, next slide. Just a few quick logistics to get out of the way before we get started. We'll have some time right at the end for some Q&A, so please submit your questions to us in the Q&A tab. Since we'll be holding questions till the end, if you have questions for a specific speaker, please let us know when you type those in. Also, this event is being recorded and we'll share the recording link on our event page and our YouTube channel. So please follow us on our social media after this event if you want to stay tuned and rewatch it or share it later. Next slide. Thank you. So here's our agenda for today. As you can see, it's a pretty packed one. We've got quite a few great innovators to hear from. Go ahead, next slide. But before we get started, I wanted to just address why are we here today? Current is here because we like to think of this one problem question. We need more healthy water to drink and less floodwater in our basements. And that's a topic that's both local and global. We're experiencing these challenges here in Chicago, but also all around the world. And that's really the theme of this series. Next slide. So the urgent need here, the challenge is that people aren't rallying fast enough around these new technologies that exist to protect us, our health, and our environment. These approaches to water solutions are really large and complex and require a lot of collaboration. So that's why Current exists, to build partnerships among industry, government, nonprofits, businesses, and researchers, folks who are willing to take rational risks to try out new solutions. Next slide. Current exists as an unbiased advocate for the best water policy solutions and policies. We stay on top of the latest in water technologies. We know the field is rapidly changing. We independently assess these technologies and then recommend the best solutions for others to try out or for us to pilot. So on that topic of best solutions, we've gathered a few great ones here today for you to hear about from some of our great partners. And that is really the topic here today, is that we're going to hear from 4 different Israeli water innovators and hear about their technologies and applications for here in the United States. Great, next slide. And before we get started, I'm going to actually introduce, for our problem statement, John Robinson, who is a partner at Masterplan Ventures, to give us a sort of brief framing of the problem and the topic for us to talk about today. John?
Thanks, Kando. Hi, everybody. John Robinson. I'm a partner at a venture capital group called Masterplan Ventures. We're Chicago-based and proud to be affiliated with Current. Thanks for the opportunity. So, as Kando mentioned, we're early stage technology investors that address some aspect of water or wastewater. That's all we do. We do see a lot of stuff out there in the market. We don't see every single deal, but we certainly see a lot of technologies out there that are solving challenges for utilities. Some of the stuff we see is doing really well. Some of the stuff is just about to take off and looks promising. Some of the technologies we see are really struggling. So we have an advantage of seeing all of the innovations out there in the competitive environment. That's part of our perspective on this, which is why we're here to frame the problem. So what is the problem? This is a question that I woke up this morning over my coffee thinking about the problem. So there's symptoms to problems, and then there's the problem. And oftentimes human beings, me included, or get them kind of mixed up a little bit. So I was thinking about it this morning, and the problem is that US water and wastewater utilities are particularly slow, or I would actually even use the word painfully slow, in adopting digital innovations. Masterplan, we don't really look at them as digital. We kind of just look at them as innovations in data science or computer engineering or ICT, information communications technologies. We come from a more data science background. I realize some people call it smart water. But essentially what you're doing is leveraging the data science toolbox to drive efficiencies and mitigate risks throughout utilities. So that's why we're so heavy on data science. And the ability for US utilities to embrace these innovative tools is hard. Most European and Israeli utilities, they have individuals on staff who have advanced degrees in data analytics and computer engineering and any number of data science related degrees. 90% plus, I would even go on to say 95% of US utilities don't really have anybody on staff who has a background in data science or digital innovations, to be broader. So the problem is that utilities are slow, US utilities are slow to adopt, but they don't really have the ability to adopt sophisticated tools. So as I was thinking about this morning, preparing for this discussion, really the adoption is really a symptom to another problem. And actually, so here's the real problem. I'm sorry to bounce around here a little bit, but the problem is that a lot of the technology providers out there are selling innovative offerings, but they're selling them the wrong way. That's our point of view. And we're happy to be challenged on that, and we're happy to be wrong on that. But of the hundreds of digital innovations that are out there in the market now, of course, they're going to get a few customers, but most of them struggle to get traction because they're trying to sell complex solutions when 90% of the US market, small, medium-sized utilities, they're looking for baby steps, incremental add-ons, and ultimately they're looking for more SaaS-related offerings. And that's a struggle for especially European and oftentimes international technology providers to sell into the US market. So they end up going to the large US cities that do have people on staff who are experienced in vetting and implementing digital solutions. So our point of view on this is that to realize a more digital adoption in the US utilities market, a new business model, a new sales model is needed. So you can't fault the utilities. You go to small town Arkansas or small town Colorado, I don't know why I'm picking on those states, to expect a cultural change and an awakening and awareness that they need. These guys know they need to do digital. They just, the options in front of them are too risky or too expensive. So as investors, what we see, and we're tracking a bunch of companies, is a new generation of digital innovations that were built from the ground up to meet the 90% of US small, medium-sized utilities. And so one of the challenges is that a lot of companies struggle with in the US market is they're trying to fit a square peg into a round hole. And so we would encourage them to rethink their strategy in the US market and try to sort of build a product and an offering with the 90% in mind, unless they're comfortable going after the large utilities, which end up being hyper competitive. If you want to go after the 90% of the market, you might have to reimagine the way you're selling. So the problem is not that utilities don't get it. The problem is that the solutions that are being sold to them are not necessarily a fit for the realities on the ground in small and medium-sized utilities. That's our point of view, and we're happy to be wrong about it. We're happy to engage in debate with other people about it. But fortunately, Current has invited 4 very innovative Israeli companies who have figured out the US market and have gotten some traction in the US market. And so without hesitation, I think it's time to move away from the problems and highlight some of the companies that have actually cracked the US market and are bringing innovative solutions to US utilities. Thanks for the opportunity. Happy to engage in further discussion.
John, thank you so much for the excellent framing and tee up for our conversation today. Before we jump into some of our speakers, I'm pleased to introduce Ariella Rada to give us a message from the Consulate General of Israel to the Midwest. Thanks.
Thank you so much, Kalindi, and good morning, everyone. On behalf of the Israeli Consulate, I'm happy to welcome you to this critical discussion, which is exploring challenges and successes in water infrastructure from the US and Israel. I want to thank Joe Brigandi, Partnership and Development Manager at Current, and his team, as well as Ra'anan Adin, CEO of Adin Holdings, for their invaluable partnership, not only in this event, but also in other economic opportunities between the US and Israel. We are also grateful for each one of our excellent speakers who will be sharing their expertise with us today. In Israel, our passion for water technologies is a combination of our challenging arid and water-scarce conditions coupled with our entrepreneurial and problem-solving spirit. The drip irrigation system is one of the most well-known innovations to come out of Israel. But in addition to that, nearly 80% of Israel's drinking water is desalinated salt water, and 90% of our wastewater is recycled. Still, like many other nations in the world, we face numerous challenges in water infrastructure, but we are not alone in this effort. Global problems require global solutions. That is why it is so important to come together for an event like this that sparks ideas and partnership to seek the best solutions by joining forces. In the Consulate's 9-state Midwest region, our economic team, which I lead, is always on the lookout for US prospects for partnership with Israeli companies and institutions. We connect Americans and Israelis in the pursuit of common goals, leading to mutually beneficial cooperations. I have no doubt that in today's program, we will see the potential for those kind of cooperations in water technology. Thank you for the opportunity to speak here today, and I'm sure that we will enjoy the rest of the program. Thank you.
Thank you so much, Ariella. Absolutely, global problems require global solutions. And on that note, I am pleased to introduce our first set of speakers, Amir Peleg, founder and CEO of Takadu, and Pat Graves, CEO of Aquify, to give us a brief presentation on remote insight and management to revolutionize the operations of US water utilities. Take it away.
Thank you, Kalindi. And I'll just start. First of all, thank you everyone to join the event. And John, I salute your analysis. To the point. So I'm on your side. And I think one of the issues that we saw in the US market is that when we brought the Takadu central event management and data analytics platform to the US market, we analyzed and we saw exactly the same challenge that John described, that 90% of the market in a way is ready, is willing, but doesn't know how to do it if you're just selling him technology. And so we took a different approach. So let me start by one or two slides about what is Takadu, and then I'll hand over to Pat, our partner from Chicago, from Exelon. George, next. So Takadu has been really one of the early pioneers in data analytics for water when we started our journey about 10 years ago. Oops. Go back one. And we have a platform that is analyzing a lot of the data that is being accumulated at the water utility. We've been around for about 10 years. We have customers around 13 countries. Remember, Takadu is an enterprise solution, so it's a heavy software hosted on the cloud using SaaS business model, analyzing almost all the different types of data. And on top of that, we are also heavily integrated with the different IT components at the utility level, whether this is their asset management, work order management, call center, any of their other detection solutions, and so on and so forth. We have a global community of users that are using Takadu 24/7, so they exchange a lot of their knowledge. Think of Takadu like CRM or like ERP. So we're one of their components at the heart of their control room. And we have customers all across the globe with some heavy names and small names and private and public all across the board. Next. A little bit of under the hood. So when we are getting all the data into our server, SCADA, meters, sensors, any type of data, real-time data that is being collected at the utility level, we are analyzing the data, cleaning the data, and most importantly, we are learning. We are feeding the data into our smart algorithms in order to generate predictions of what a good network is supposed to behave like. And that allows us that in real time, we can detect anomalies. We can detect when something goes wrong by different data science techniques, big data or statistical techniques, you can call it whatever you want. And later we are integrating that anomaly detection, that insight that something is wrong together with other pieces of information, not necessarily raw data, information from acoustic loggers, information from pressure issues, work orders, customer calls, any type of information that could help the user to better figure out what is wrong with his network, and then everything is displayed. And after giving a bit of that introduction of what is the platform doing, I will hand over to my partner, Pat, who will introduce the whole new concept and the model that we picked for the US market, which is not to sell a technology, but to sell a full service.
Fantastic. Pat. Thank you, Amir, and thank you to the current team. Pleasure to be here. So if you go to the next slide. So again, my name is Pat Graves. I'm the co-founder of Aquify. We're an Exelon company. So why is Exelon here talking on this panel of Israeli technologists? It's because, as John mentioned and Amir mentioned, we think that software alone is not enough. You don't just email out a username and password and expect the utility to all of a sudden save water or find breaks and things like that. It takes more. It takes the staff time to actually use the software, the resource, the skilled resource who's good at analytics and maybe has an advanced degree in data science. It takes metering expertise to actually get hardware into the field that actually provides any missing data that might be needed. Or it takes IT architecture and cybersecurity expertise. And that's just to get it stood up. Once you have the sensors and the software deployed, who's going to actually sit and analyze this data on an ongoing basis? There's process involved. There's people that are required to get the value out of the software. That's what we found as Exelon trying to deliver electricity and gas to 10 million customers across the US. It takes process, it takes the integration of people, process, and technology. And that's really what we do. As Exelon, we're the largest utility company in the US, and we don't produce hardware and software typically. There's some things we create, but we often source the best technology from around the world, and we put it to work in the real world with all of our people and trucks and our dirty boots. And so that's what we've done. We found Takadu, and we're very impressed by their software. We found hardware partners. We deliver a turnkey service. So you can sign up with Aquify, and we will help to deliver and implement and operate for the entire term of a long-standing partnership. And we found that the same approach, again, has worked. We've acquired multiple electric utilities over our course of Exelon's history. And when we begin with those utilities, sometimes our operational performance is okay. It's mediocre. But we've brought those up to be top decile in utility operations and customer satisfaction. So we're convinced that it works, that the smart thing works. It just takes more than the technology. So if you go to the next slide, the things that we're trying to help water utilities with are, as Amir mentioned, primarily non-revenue water and water accounting. So on the previous slide there, finding leaks, finding breaks immediately, not waiting for, say, annual surveys as is typically done for leak detection today in the US, where someone goes around with a listening device, hydrant to hydrant, once a year, and they find leaks. We're monitoring 24/7. So we find issues immediately when they develop. We can, not only does it help save water, but it also helps to detect breaks quickly. It's okay, George, if we leave it on this slide. The purpose of the previous slide was really just to say, it's more than, we were pleasantly surprised to find much more than water loss and leak detection as benefits of the Takadu solution and the Aquify solution. By having all these monitoring points out into the distribution network and using machine learning and advanced analytics, we're able to find all types of things. PRVs failing, so pressure issues that might have caused pipes to burst in people's homes, or low water pressure, or perhaps slow flow speeds that could cause water age to increase beyond what would be allowable in order to maintain disinfectant residual levels. All these types of things, when you have the data, we find so much value. And so, again, this is where we believe this model is so helpful, because not only are we providing the hardware in the field, which on this slide are those little icons you see that are sending data up to the cloud. We've got the hardware, we've got the software, but we've got the people. We have a 24/7 professionally staffed control center where we as Exelon are helping to monitor your water system. We're an extension of your staff. And so not only are we there for deployment, we're there for operations. So if you go to the next slide again, here's an example of how it works a day in the life. So in this example, you see a blue line that is total supply into a particular portion of Elk Grove's water distribution system. And you can see the Takadu prediction is very closely hugging that blue line. The green line is the prediction. It's very closely trending. And it accounts for, historic patterns as well as network patterns. So if it's a hot day and all of these zones are using more water, the prediction will adjust. But in this example, we see there's a leak that started one day, I believe it was the 24th of February, it's a Wednesday, and it's maybe 100 gallons a minute. Our team sees that, they alert the village, we're watching this, it's not worth acting yet. We want to monitor for a couple more days to make sure it's not a temporary event. We monitor, all of a sudden there's a large main break. A few days later, it's over 1,000 gallons a minute, so it's fixed immediately. Job well done, right? Then the next day, the flow remains elevated. So we see that immediately, we get back in touch with the village, we give them more specific localized guidance. They're able to then go and find this leak that you see in the picture on the right. That's actually over 200 gallons a minute. It looks like a puddle on a day when snow is melting and would be easily missed, but this would have lost 1.5 million gallons a week or $165,000 after a few months. So it's a sneaky leak that without data, without the support, we don't think we would have caught. But with Takadu and with the great partner Elk Grove, we're able to find this and save a whole bunch of money. So then I'll conclude on the next slide here, just to say, I think what's unique about the model that we've developed with Takadu is that we've talked to a lot of municipalities, a lot of utilities, and we've identified these challenges, the deployment challenge and the risks of actually getting the sensors installed, getting the software up and running in a way that's not going to impact quality. Hardware and software maintenance, the risk of things failing over time and now you're left with the bag and you've got more of a headache than a help. Or you've got this fancy tool but no one to use it. So we provide the 24/7 monitoring and the specialized staff. And we also finance it in a way that there's no capital required up front. So the savings stream is always greater than the cost stream. So you're never out of pocket. So again, I want to just thank the team here, and I'll conclude and let the next panelist go.
Thank you so much. That was a really interesting framing, especially the conversation around selling a service and rather than a technology or a software, really important. Please submit any questions that you have in the chat. We've already gotten a few I see, but please continue to do that. In the meantime, I'm excited to announce our next speaker, Shal Ram, the CTO of Really Technologies and Realtech, to give us a brief presentation on holistic solutions for digital transformation in water and sewage utilities. Shal, take it away.
Thank you very much. Good morning. Actually, good afternoon here. Good morning to you. John said correctly things about data analytics, about data science. Amir and Pat both spoke about data analytics as well. But don't forget that in order to have data analytics, in order to have the analytics, in order to have the science, you have to have the data. And we are dealing with the data. We are a system. Basically, Realtech is a system that can be used as SCADA system, but can be used also for remote monitoring and bring the data for the analytics and for the data science people to manage. Next, please. Basically, we are an industrial IoT technology solution which running on the cloud, and we work the same as the Kando work. We work on the cloud, work on business model that is a SaaS service, as a software as a service, and basically we give our customers the possibility to remote monitoring, remote control their facilities globally or countrywide without being forced to invest a lot of money in infrastructure and IT infrastructures. We are present in the United States since 2010, and we're currently working for different countries. You can see in the map in the right side, this is real time, actually not from now, from the time it was taken, but it was a real time status of our activities, our unit, our sites spread all over the globe, and the different colors reflect basically different situation. And if you're talking about dashboards and managerial dashboard, this is exactly what you expect to have. You expect to have a snapshot and know what is red is wrong, what is green is good, and in the middle, there are some problems. Next. Okay, there were two clicks, but this is okay. As I mentioned, Realtech is much more than a SCADA, because as a SCADA, you must have the different layers of the communication. You have to have the data acquisition, the real-time remote control, the communication, the telemetry, the data management, everything else, including the data analytics and cybersecurity. And normally you should go to, for each one of these solutions, you should go to a different company, different integrator to make these things for you. If you are a small, medium utility, as John said in the beginning, sometimes it's a little bit complex, sometimes a little bit unreachable for small utilities, especially, and maybe also for a mid-range utility. So we do it for you. We do it for the customer. We do it for the utility. We supply everything end-to-end, bumper to bumper, A to Z, whatever you call it. We supply the complete solution. From the left side, you can see number one is what we call data producer. Is the piece of hardware that we put in every site that you have. Then everything is going to the comp, to number two, which is the central online management portal. And this comp is mediating all the communication and all the things and the security, and everything is done there. And the right side, you can have the user interfaces, the HMIs, the third-party customer software, and the ERPs and whatever else. Next, please. Normally, as I mentioned, if you would like to establish one of those systems, you have to go to supplier number one for some technology, supplier number two for the telemetry, supplier number three for something else, number four, SCADA, 5, 6, and 7. So you have to buy servers, data acquisition, telemetry, all the things that you have to put in the stuff. And if you click again, then we will go to what we support, and we take everything that you see here and put it in our holistic solution and bring you the possibility to use it as a service and not to purchase everything and not to maintain everything and not to put some heavy, I would say, expense IT teams and things like that. Next, please. The system is very, very flexible. It's agnostic and it's seamless interface with existing equipment. We did a lot of projects also in the United States when we connected our system and solution to existing software, to existing control system in water utilities and sewage utilities. We can work in parallel and in conjunction with all SCADA systems. The system is real-time and it's used for both remote and control. 100% modular with no limits of devices and users and sites and whatever. Very easy to use, maintenance free because we maintain for you. The cybersecurity is one of the important things that we work on, and we have the approval from the Israeli Ministry of Energy. We have the approval from the Israeli Water Authority, and wherever we go, we put a lot of effort into security, and the customer, the utility gets it as a package. Secured system working without it being forced to put a lot of things around it. The system, however, is very affordable. It has low capex and low opex, and the thing is that the payment for the service is very, very low compared to the investment you had to do with the traditional, I would say, solution. Next. There are some challenges. Not everything is going smoothly. If you click again, we can see some of them. 50% of SCADA system in water utilities in the United States are 10 years old. And this is really, really old. Not mentioning working with some oldest Windows-based system and things like that. About 45% of small utilities even don't have SCADA at all. And this is a little bit risky in our days. And the new generation of SCADA is what we basically deliver. It's a cloud solution, as I mentioned, that you can forget about old SCADA and all installation and put everything in the cloud, having big data, and may then go to the analytics, then go to the data science. Next. The challenges are different, but if we count some of them, we can see that less than percent or less than 0.5% of the data is ever analyzed, because when you have too big, I would say, data, then it's very, very difficult to analyze it. 88% of the utilities have not implemented data management system because of these obstacles, I would say. As I mentioned, in our system, it's a holistic system that supports real-time control, telemetry, HMI, trend reports, data acquisition, data analytics, everything in a single shot. Next. Challenge number 2 is the integration of the industrial IoT system. Then we have the budget issue that we have to face, the lack of skills that we have to face, and the security, the cyber security, and I would say even safety, not only security, but also safety. And Realtek solved this in a affordable, smart and simple way. And because it was built to the cloud, it was built for cyber security. I would like to mention the cyber attack that were on water facilities in Israel a year ago, and since the last year several times. Our system was not affected at all, and I think it's nearly the only system that was not affected by these cyber attacks. Next, please. Capabilities and a little bit of what we did in the past years. Next. What we see here is a system in Israel, and basically I think we have here, yes, something like 100 water and sewage and wastewater systems. You can see in the left side the dashboard with the map. You can see in the right side a little bit larger map. In a snapshot, as I mentioned before, a manager can know what is okay in green, what has alerts, what is not communicated and have to be fixed. And this is very important. Of course, if you put some more values into the map, you can see in geographical presentation immediately in 2-3 seconds, you can have most of the important information you would like to know about your system. Next. You can see in the left side, if you go clockwise from single device, this is a water meter, water well, pressure sensors that are connected to the system. In the right side, you can see the entire network, how it's connected with all the facilities. Each one of them has one of these small units that communicate with the cloud and make it possible for the managers and for the maintenance and operation guys to go over the system. And then if you go to the lower part, the 3 images in the low, you can see some graphical screens that makes you the possibility to see very friendly, very, I would say, processly. If you are a process guy, what is happening in the system. The right side is a reservoir with pumping station. The middle one is a wastewater treatment plant with biodiscs. And the left side is a well. Next one. Talking about some analytics and some dashboards, then you can see some of the possibilities in our system. You can see it as a trend. You can see it as images. You can see it as historical reports with tables with some statistic like minimum, maximum, average, standard deviation, all kind of statistics, rate of changes and things like that you can calculate in the system and have some kind of analytics already embedded in the system before you take it to the really large data science processes outside. And the right side, you can see the right downside, you can see a presentation of a small dashboard which involve several trends and some gauges and some values. And immediately you can see what is green, what is red, what is yellow, what is okay, what is not okay. It's very, very visible. And it provides you significant benefits when you would like to make operation, management, and other things. It saves you cost, the quality is good, the speed is good, and the reliability and security is, of course, one of the highest. Next. If you come to a place when they have old, I would say, SCADA system, then we can have the new one in the right side, the left one, the old one in the left side. And as you can see, you can work with both of them. You can combine both of them, and you can fade out the old SCADA system as fast as the new installation with the new SCADA system are installed. And that maybe save you a lot of money by not being forced to change everything on a single point of time, but to make it slowly, and to fade out the old thing and to fade in the new things. Next. The next case is from Mexico, and actually we are walking around Mexico City, This is a place when it's limited corporate governance. Only basic data analytics and report were made, of course, manually. There were poor maintenance and service level with high operation cost. And the critical events, well, sometimes it went, who knows where. Next. So the results of what we do is what we did is what you see in the right side in the geographical presentation. When you see some stations or most of the stations that are in the project, and you can see immediately what is green, what is red, same as the others, what is okay, what is not okay, what has to be handled by name, by geographical presentation. Of course, you can see it in a lot of other ways. It increases the operational and safety operation. It make the service excellent with no interruption, and you can have, the customer has automatically daily reports, the utility has daily reports and data analytics, and it saved about 50% of water and electrical power. And this is very important because it saves money. And this is the most important thing, service and saving cost. Next. COVID-19, of course, was a changer for the world, but we were there before, and we were supplying our customer the possibility to work from home, like they are in the office, without the need to be in the control rooms of the utility, because every personal computer, every notebook, every tablet, every cellular phone like this can be actually a control room safely, securely, and very, very convenient to operate. Next. By that, I finished my presentation, and I hope it was, it opened a little bit about the, not only the data analytics and data science, but also the part of the data that has to be handled together with the part of the control that has to be handled in parallel. Thank you very much.
Thank you so much, Charles. That was a great ending to end on a cartoon. Love it. Please continue to submit your questions in the chat. I know we've had a couple already, but please continue to submit those. I'm pleased to introduce our next speaker, Annalie Maron from, our U.S. Business and Development and Marketing Strategist from Kando. Thank you so much for joining us today.
Thank you for the introduction. Hi, everyone. Good morning to most of you. I hope everyone's doing fine, has a good start of the week. I'm Annalie Maron from Kando, and we are a smart wastewater management solution supporting utilities and providing insights on what's happening in the wastewater network or collection system that we're all using. And through that, we're helping them really protect the environment from polluted events and help protecting public health by providing improved water quality. Next, please. So I'm going to talk a little bit now first about why it's actually important to get some insight on what's going on from the collection system. As you all might know, everyone's using the collection system. We might not think about it. We're using it on a daily basis when we go to the bathroom, when we take a shower, but also industrial areas are using this collection system very heavily to discharge the same thing that we as human beings are using the collection system. And the problem is that it's a very harsh environment. It's underground, very hard to access, and therefore often discharges or events happen in this collection system that are unknown and only are being found out when they get to the wastewater treatment plant during the treatment, which often leads to the fact that it's too late and it creates a lot of damage. It could create environmental pollution when the effluent gets out of the wastewater treatment plant, when the influent gets into the wastewater treatment plant with polluted events like acidic. They could harm the bacteria in the wastewater treatment plant. It could, damage your infrastructure and eventually also lead to public health risk. So therefore, we feel that it's very important to look into this and provide these insights to the utility to help them sort of create a preventive strategy rather than a reactive strategy. So next. please. So before I go into a bit about how we do it, I want to create a bit of an impression on the impact that these discharges could have on the pollution. So we've been around for about 10 years, since 2012. We started in Israel. We worked with a lot of utilities all around the world. And we've really seen that the industrial discharges that are being discharged to the collection system are often connected to sectors and have different types of impact on the wastewater treatment plant. So here I've just taken 3 sectors where we've looked into hospitality industry, the pharmaceutical industry, and petrochemical industry. And they all have very different types of discharge in the collection system that impact the wastewater treatment plant. For example, hospitality industry, they use a lot of fat to cook, to fry, and they discharge in the collection system. It can lead to increase of organic loads, excessive sludge, which is heavy, it creates heavy loads to be treated in the wastewater treatment plant. Whereas, for example, the pharmaceutical sector can provide toxic sludge that could kill some of the bacteria in the collection system. It could really increase the cost of the treatment process. So in the end, even though they have different impacts, the outcome is somewhat the same. It could affect the wastewater treatment plant. It could increase the cost of electricity because you have a lot more loads coming into the wastewater treatment plant that needs aeration, or you need to repair costs because of the damage that it's done to the infrastructure. So all these type of things are very important to know when you're working in a wastewater treatment plant and you really want to improve your efficiency, because sometimes if you don't monitor the collection system and you don't have the insights or you don't have the data, you are unaware. And all of a sudden you realize something is happening and you couldn't prevent it. And now you're there with the impact. Next slide, please. So how we do that? So we, as I already mentioned before, we use data to provide insights to the utilities and to support them in this. We're an end-to-end solution, which means that we provide hardware, software, and insights, including a dashboard, customer service to really support utilities and wherever they need. And I'll stop first where we're supporting them with more of the hardware in order to extract the data. Because if you want to use data, you need to get good data. And that's where our hardware comes in. So we have flow sensors, data loggers, automatic samplers that are all going to be installed in a manhole. Next slide, please. Which then all are going to be translated this data is being retrieved from the collection system. It's translated by our machine learning system in the cloud, where there is a data analysis that provides the insights to the utility. So what you see here is a couple of screenshots that the utilities get in order to understand what's going on into the collection system. So what happens here is that as soon as a discharge happens in a collection system, we can identify it, mainly because we analyze the behavior of the network. So we can see what's the normal behavior of the network, a rhythm. Factory starts up at 9 a.m., closes at 5 p.m. And then all of a sudden we can also see abnormal behavior, and this identifies a high risk event. So this is what we identify in the collection system. We take, our system takes an automatic sample as soon as an abnormality is being detected, and it sends out an alarm to the operators in the field or from the utility, depending on how they've structured it. So how do we actually help this with is we can help minimize pollution events in the collection system, which improves, of course, wastewater quality. It helps asset protection. We can help protect your assets, and we can lower, for example, OPEX by 20%, CAPEX by 10%, and also we can help reduce energy rejection. I briefly mentioned about the aeration of the wastewater treatment plant. It costs a lot of energy, and by reducing the load and by creating transparency within the industrial users and the utility and creating that communication between them, we can really help to change behavior on both sides, which I think is one of the biggest benefits that we can have within our system that supports the utilities, because they're basically, with our data, they're creating transparency between all stakeholders to understand what the impact of their behavior is on the network and the wastewater quality. Next, please. So I want to take you here a little bit more, and I'm going to take also, everyone be prepared because I'm going to ask something of you. Here you can see a chart where we're discussing the discharge events or impactful events we find in the wastewater collection system when we do grab sampling. Grab sampling means that they're being done once a week, once a month, every quarter on a random day, random hour to figure out what's going on in the collection system. So here you can see an overview of the events that among the industries that we find. Now, I'm going to ask a question. I'm going to say stop at maybe 8 answers. If you continuously monitor the collection system 24/7 and analyze the behavior, how much do you think it will jump? 20%, 40%? Any thoughts? I'll give everyone 10 seconds. I'm asking this because I do think it's very important for people to understand or see what the impact has from data. I don't see any movement yet. Okay, I think 33%, I have one. Someone else? 20%, all right, thank you. Can we go to the next slide, please? So based on our analysis and our monitoring of the collection system and our automatic sampler, so remember that we have a machine learning system that extracts the data, monitors the network behavior, and then detects the abnormal behavior where we fingerprint events. We find of a minimum of 60% more pollution events in the collection system that helps the utility improve their strategy on how to operate efficiently. So here I think we can really demonstrate how important it is to have this type of data and to have these type of insights for the utility to really improve their operations and efficiency. Next slide, please. So how we get to that, because I want to take a step back, I'm going to talk a little bit about a case study later, but I think it's important also to discuss a bit of our journey, because this was also something mentioned by John, US market and our approach. So we initially started in Israel, basically based on a frustration from our CEO, who used to work at wastewater treatment plants and was encountering all these unknown events. He said there must be something out there to do it. So he started working with the utility in Israel, where we really developed together with the utility the product to address the challenges and the problems that they're having. Fast forward to 2018, we covered a large part of the Israeli market, working with most of the utilities there, and started entering into the international market. And this is where we started working with also partners, which I think is an important aspect. Like Amir also said, for every single market, because we're an Israeli company, we don't necessarily know everything about the market. Our partners do, and can really provide hands-on support on the ground when needed. Like John also mentioned, sometimes utilities, they don't really know how to approach it, and really with a local partner, you can really provide this stability, customer service, and experience also in how to use a system, in this case like ours. So currently we have another office in the US. We have a couple of large projects in the US, which I'm going to talk about later, and we are very heavily entering into the European market, Italy, Spain, Germany, the Netherlands, very heavily in Spain, where we see that our system is also being used for a little bit of a different objective. For example, what we see here in the US. Next slide, please. So here I'm going to talk a little bit more about our wastewater case study with the city of El Paso. El Paso is a city in Texas. They have about a population of 800,000. They have 4 wastewater treatment plants, and they have a very heavy industrial area. Now, El Paso is doing something very innovative. They are focusing on reusing the wastewater for potable reuses. So our people are going to drink it, but therefore the wastewater quality is very important, and also to understand the full life cycle. Now, when we came in and we provided them, we deployed our system there, we were really able to help them, first of all, understand what the status is of the wastewater quality and where to improve it. Small example, for example, they had cooling towers connected to the collection system, which were masking a lot of the pollution events, which therefore could be monitored by the several sensors or the data extractors that were had. So as soon as our system realizes this, they could adjust it, and then we saw the actual pollution events. And in the past 6 months that we've already been able to identify very severe pollution events, for example, from the petrochemical industry there, that could have a severe impact on the wastewater treatment plants and save them a lot of money because they were able to divert, for example, this influent into the wastewater treatment plants. So I think this really demonstrates how impactful it is to use this type of data for utilities. Here you see a small screen. You can see as soon as we detect an event, it's being detected today. It takes 3 to 4 hours to get to the collection system. An automatic sample is being taken that needs to be picked up to send to the lab for verification to identify what it is, even though our system also provides information on the type event that is being detected. And this is really what we see where we're working with El Paso and improving wastewater quality, and also providing a good, we're helping them meeting the standards of meeting the regulations for potable water reuse, which I personally find it's very cool. Next slide, please. So where are we going? As I mentioned, we started in Israel. We have projects all over the world, France, Italy, Germany, Greece, Spain. We're heavily on the US now, and specifically Italy. And we're going to continue opening the market here and hopefully work together with more and more utilities that see the need of using this type of data to improve their wastewater treatment plant operations. Next. So feel free if there are any questions, if you have any questions about the machine learning system that we're using or how we identify pollution events, which we call fingerprinting, feel free to drop me a note or to drop a question in the chat box. Thank you.
Thank you so much, Annalie. We have one last presenter today. This is our fourth innovator. I'm pleased to introduce Eddie Segal, the VP of Sales and Business Development, and James Perry, the VP of Business Development at Utilis, to give us a brief presentation on satellite data to reduce water leakage and wastewater pollution and improve pipe replacement programs.
Thank you, Kalindi. A few words from sunny Israel. Good afternoon, everyone. I run business in the rest of the world, and when I saw the first slide of this session, water around the world, I thought, okay, this is my game. But then in the small letters, it says sustainable water infrastructure in American cities. So, well, I will have to get help from my friend, James Perry, who runs Utilis business in North America, out from our own office in San Diego, California. Go ahead, James, you take it.
Thanks so much, Eddie. You can click 2 slides, please. First, I wanted to thank the group at Current. Really, water infrastructure and water infrastructure management has been key to what they've been doing now for many years. Eddie and I both, with great excitement, have been with the organization since the 2015-2016 timeframe. Our goal really, besides the fact that we love traveling thousands and thousands of kilometers and miles around the world, was really with an enormous hunger to look for various applications for synthetic aperture radar. And in doing so, we were interviewing and asking customers and end users what would they need to be able to make money back, save money, or become regulatory compliant. And certainly what Utilis has done since 2016 in launching our product through synthetic aperture radar has been to meet the need of disruptive innovation for the significant challenges in asset management and water infrastructure management. So what we've been able to do is harness the power of synthetic aperture radar. This radar is using various wavelengths. And for those of you who may not have seen or heard what we do, we're capturing, in one click, please, the wavelength particular to L-band. And L-band for us in this wavelength, on the next slide, please, allows us to be able to not only actively send of wavelength and capture the returned wavelength with imagery, but really to be able to isolate down to a very specific frequency and band that allows us to penetrate through canopy, through soil, through asphalt, into ground, reflecting specifically off the signature of water. These various frequencies will reflect off gases, solids, and liquids different, and various bands are tuned to those. L band is tuned towards water. Now, the vehicle, next slide, please. The vehicle that we use is to place this sensor on a satellite. Utilis acquires this image. The benefits of using a radar satellite, click please, is that it is all weather capable, highly sensitive to the dielectric properties of water. Very important. The construction of that water allows us to be able to report the various waters, whether it's all moisture, drinking water, or wastewater, and identify those significantly. It runs day or night, penetrates through clouds, and as I had mentioned, subsurface penetration. Next. The benefit for us since 2016 has been able to really adopt this particular application to look for leakage to below ground. This is where we cut our teeth. It was clearly the most difficult and most challenging thing to do. We've had the good fortune of well over 400 projects across 55 countries around the world. While we're honored to be able to do that, we are demonstrating our ability to work in various soil types, various water tables, various terrains, topographies around the world. The uniqueness within each utility has allowed us to really cut our teeth and learn from our customers. But not only have we been able to verify now well over 30,000 leaks via our points of interest, we've saved significant amounts of coal by returning and fixing the leakage, as well as the water and the associated revenue to that as well too. And we've done that very simply by going from a very analog approach to leak detection in the market and using our satellite guided or digital approach makes crews much more efficient in the ground for us. This, with great excitement, I'd like to announce that as of June 1st, we receive and were humbled by the great honor of the first ever innovation award by AWWA. The American Water Works Association has bequeathed unto us the honor of the award of the most innovative product of the year. This is something that really was built on multiple years of learning the market on leak detection. But as you well know, if you could click to the next slide, please, there are many, many other applications that we can attain from what we are doing. We recognize that it's not just leak detection that's important. While that's a key area to us and where we started our journey, we recognize that there's a significant amount of opportunity to be able to look more broadly at asset management and the associated programs for water infrastructure, whether it's risk assessment, workforce engagement and efficiencies, lower life cycle costs, and on. These asset management issues are important across the board with aging infrastructure, limited budgets to be able to replace pipe, the need for sustainability. This is key for us in terms of overall responsibilities that we have in the marketplace. Knowing and recognizing that our advantage of using a sensor that is satellite mounted, looking below ground, is key as a data input. Next slide, please. So we're very pleased to this May to have launched yet another application in the marketplace, highly distinct from the leak detection work that we've done. We've gone more broad now as an asset deployable management tool. Next slide. And MasterPlan for us allows utilities an additional data layer to use as a GIS data layer to help prioritize your pipe replacement, direct deployment of fixed assets, and to be able to use this as a non-invasive indicator of leaks below ground. Again, below ground, seeing what you can't see. And based on the tens of thousands of leaks that we have found, we now have a profile that we can use and provide this to utilities and or consulting engineering firms as hydrology reporting, and as well an ability to be able to look at the entire system. Keep in mind, our imagery is about 1,400 square miles in one snapshot. Often we can get an entire utility in one snapshot, and that begins to develop a profile, click please, that allows us to be able to look at capital planning and improvements as a data input to your forecasts, and a risk assessment piece to this as well too. Additionally, this is a tool for operations and maintenance. So not only are you looking at the ability to replace pipes, but you're also able to operationally develop maintenance programs to know where you want to go first. How do I prioritize the thousands of miles and kilometers of our system? Where do I go first? Even if I have points of interest from various data inputs, how do I know the more stressed areas? So we are also providing that via MasterPlan as well too. And as I continue to say, our responsibility for resiliency to be able to risk assess these more sensitive areas of a system, to be able to develop a clear action plan. Next slide, please. So what we're doing is now every single meter, inch, foot, mile, we are able to provide a deficiency level. These levels are ranked from no deficiency to high deficiency. So now you have an entire system deficiency based on a sensor and radar, satellite mounted, looking below ground for the signature of leakage. And that allows us to be able to do something quite unique. Next slide, please. As an Esri Silver Partner Program, as an Innovize Business Partner Program, we partner as a data layer, providing GIS information and a scoring level that can be imported into any GIS software or asset management tool. You heard of many others. In fact, this morning, that we also can provide a data layer and asset management to be able to plug into these. And our partnerships are deep and wide in order to be able to do that. Being agnostic, we to any software, we provide a data layer directly into that. So next slide. So how did we do what we developed with MasterPlan? Well, based on customer data, multiple overpasses have been taken, and where we have verified specifically points of interest and found leakage, we looked at the importance of clusters in these multiple images that we see. We took a look at the ideal buffer size, and many other factors that allows us to come up with the conclusion that with two passes, distinct passes, that repeat, that are an exact repeat, we're able to take a look and analyze these clusters accordingly. Next slide. And you can click, well, you can stay there, please. What we've been able to do is to take a look at a spatial cluster, which is one image with two intersecting points of interest, again, where we are seeing the signature of drinking water below ground. We've been able to see single points of interest, spatial points of interest that are intersecting. And when we have multiple images, we now have two distinct data sets, two snapshots in time that allow us to be able to score pipelines accordingly. Next slide. One more. And click two more times, please. Thank you. What we have been able to see is these distinct images that are overlapping directly over each other, a minimum of 3 months apart and a maximum of 12 months apart, give us an amazing data set where we can look at single, spatial, and temporal clusters. And when we've done this, we now, next slide, are able to provide a data layer for MasterPlan that is a distinct data set used in any one of the softwares. Click, please. And one more time. And now these data layers, you can click on and click off for any of that, give you a significant piece of information for risk management. So not only are we providing points of interest, we're taking a look at multiple images and the impact of these points of interest that allow you now to cover your entire system, allowing you to have an asset management tool with a risk assessment scoring of your entire system. I'll click one more time. And with that, once more, I'd like to thank you. We look forward to not only continuing on the leak detection, but also the asset management, entire scoring of your entire system. And you can also look for much more and many more applications coming from us. Again, thank goodness for this technology coming from the great state of Israel, and with partners like Current and the hard work of all of us traveling to really drive disruptive innovation and being the point of the spear, if you will, for being able to tackle these challenges. Thank you again.
Thank you so much, James and Eddie, and all of our speakers. We're slightly over time, but I have one question that I'm actually going to open up to all of you. We had some conversation in the chat earlier in the session today about the challenges to adopting these technologies. Things that were mentioned were that there possibly, is it the lack of consequences for not adopting these technologies? Is it the challenge of small budgets? Or the fact that utilities are too busy handling emergencies to have time to sit down and select the right technologies? I'm actually going to flip that question. And if you can all answer me in 20 seconds, since we've got a little bit of time here. In the successful adoptions of your technology, what was the selling point that worked? What convinced your clients to try out your technology? We're hoping to learn here from the really successful cases. So I'll open it up to anyone who wants to answer that. And again, 20 to 30 seconds if you've got it for us. Thanks.
Well, if it's okay, I jump right in since I finished. Off of what Utilis has done, really, it was built around discussing in great detail with our customers and understanding what their challenges were. And as I had mentioned, making them regulatory compliant, making them money and saving them money were really the key attributes for us. Our value proposition started on leak detection with the lowest cost per leak found in the industry. It was tried and true over benchmarking from traditional methodologies on leak detection, and by using our satellite guided approach was a screening tool to drive utilities to be more efficient with a traditional acoustic leak detection. And as I mentioned, that tool allowed us to be the lowest cost per leak found over time.
I would say if
go ahead.
Talking about Reality, I think there were two main issues. One of them is the fast installation, the fast operation of the system, and secondly, the possibility to do it without being forced to raise funds, because most of the utilities can do it from current budgets.
From the Aquify Takati side, I would say, not assuming that the utilities would be happy just to have the technology delivered and they take it from there. Not assuming that they have staff sitting around with time to spare to focus on something besides their day jobs. So providing, listening to what they're saying and providing a more full solution, partnering for the long haul has been where we found the most success.
I think I can echo what everyone said, and specifically collaboration with the utility to really understand where their challenges are and to really support them in them. Because in the end, the utilities need to do the work. We're only there to help them become a bit more efficient and to improve the operations. So I think collaboration is key, and have a good relationship with them.
Great. Any last thoughts there? All right. Well, I think with that, then we're ready to wrap up. going to share just a little bit of last information with you here. We've got some upcoming events, specifically our next Third Coast Water Seminar. Feel free to scan this QR code and you'll head to our events page where you'll see all of our upcoming events. My colleague George is just going to launch a poll right now. So feel free to take that poll and let us know how you liked the session. Great. And with that, I think we're just wrapping up now. If you are interested in collaborating with us, if you liked the session and you want to learn more, please contact my colleague George right there. His email's right on the screen, and we'd love to get in touch and learn more about you. Thank you so much for participating, and thank you to all of our speakers for sharing their insights with us today. We hope to chat with all of you in the future. Thank you.